Humanity has been haunted by the tantalizing prospect of cold fusion for over 3 decades. The promise was intoxicating, limitless clean energy, reactors small enough to fit in a garage, and abundant power that would transform civilization. No more oil wars, no more climate collapse, no more bowing to fossil fuel empires, just endless light, ripped from the atom. It was supposed to be our Promethean moment. Instead, however, it became one of the most extraordinary ghost stories in the history of modern science. On a blustery day in March 1989, 2 renowned chemists, Stanley Pons and Martin Fleischmann, presented their findings to a packed audience at the University of Utah. Their claim was not modest. It was world-changing. They announced that they had achieved cold fusion in a laboratory, a room-temperature nuclear reaction using a tabletop device. They promised a future of unlimited clean energy, a reactor the size of a coffee pot with no radioactive waste, no billion-dollar machines, and no meltdowns. All that would be needed is a palladium rod, heavy water, and electricity. They said the device produced more energy than it consumed. Excess heat that could only mean one thing: a nuclear reaction in a glass jar. Reporters feasted on this story. Politicians saw history in the making. The public saw salvation. However, physics saw blasphemy. To understand the outrage, you need to know the basics. For fusion to occur, 2 positively charged nuclei must overcome their immense repulsion, known as the Coulomb barrier. Stars achieve this through gravity and temperatures of millions of degrees. Humanity's best attempt requires enormous reactors costing billions. Pons and Fleischmann claim to have achieved the same feat at room temperature. This should have released deadly streams of neutrons and gamma rays, the hallmarks of nuclear fire. Instead, however, there was only excess heat without radiation. In physics, a half miracle means no miracle at all. Their claim challenged more than just theory. It violated the structure of the physical world. Rather than ridicule, science responded with replication. MIT, Caltech, the University of Geneva, and dozens of other laboratories raced to test the claim. One by one, however, they found nothing. There was no excess heat or nuclear signatures, flawed measurements, poor controls, and wishful thinking. By 1990, it was clear that cold fusion wasn't real. Pons and Fleischmann weren't just wrong, their careers were ruined. Their careers collapsed as fast as their reputations, turning them from rising stars to scientific exiles. Cold fusion became a monument to overreach and a brutal reminder that, in science, replication is king. For most, that was the end. But not for everyone. A stubborn faction rebranded the field as low-energy nuclear reactions, LENR, or condensed matter nuclear science. New names, old hope. They held fringe conferences, published niche papers, and whispered of conspiracies. Every few years, a startup or eccentric billionaire claimed a breakthrough. In 2019, even Google funded a multi-million-dollar study. The result was always the same: no reproducible evidence or functioning device. Yet, the allure of cold fusion persisted. Adapting the terminology to low-energy nuclear reactions or condensed matter nuclear science, a faction of believers continued to pursue it, fueled by hope and speculative breakthroughs despite consistently lacking evidence. The cold fusion saga teaches a poignant lesson. Science does not yield to hope. It reflects our collective longing for a miraculous solution to pressing global challenges. Although often ridiculed, the dream of cold fusion endures because it encapsulates humanity's desire for simple salvation in the face of complex problems. Despite its failures, cold fusion remains a potent symbol of our yearning for a quick fix to energy crises, even as real solutions demand hard work and innovation.